Welcome to week 2, combining like terms. I'm sure you're on the edge of your seat. A couple of questions we hope to answer during this video. What are like terms and how do you combine them? Let's take a look. The first question, what are like terms? That's a pretty simple answer. First, what we're doing is we're going to look for constants, right? And who are our constants? Just numbers, right? 2 is a constant because it's always going to have a value of 2. Constantly worth 2. 7 is a constant. It is always going to be constantly worth 7. And since 2 and 7 are both constants, we would consider them like terms. So I'm just going to underline them with a single line. Onward to some other like terms. I see that we have a 7x here. Do we have any other identical variables that are to the same power? Are there any other x's here that are to the first power? This is technically to the first. Even though we don't see it, it's assumed. And I don't think so. Lastly, we have 5x squared. So I'm going to put a triple line under that one. Are there any other x squares? Sure. There's a negative 2x squared right here and a positive x squared here. So using this underlining method, I've identified who the like terms are. They're either constants or they're identical variables that are to the same power. Now on to the second question. How do we combine them? That's even easier. But to answer that question, what we're going to do is delve back into our previous video and sort of link all the knowledge together. In our integer video, week 1, we discussed that the sum of negative 8 and 3 is actually the difference of the two values since they have opposite signs. The answer is going to have the sign of the larger number, the absolute value, in terms of absolute value that is. So the absolute value of negative 8 is 8. 8 is bigger than 3. Since 8 is negative, so is their difference. And then we sort of came off on the side and said that the difference of 8 and 3 is 5. So negative 8 plus 3 is negative 5. What we're going to do with our combining like terms is something very similar. We're going to combine our constants and add coefficients. So first let's take a look at the vocabulary word coefficient. You may want to press pause and write down the vocabulary as we're going. And then come back to the video when you're ready. Alright. Coefficient, the simplest definition I could find for you, is a number used to multiply a variable. So down here we have 12 times, I just put that little dot there, that means times, again, implied 12 times x squared, or just stated as we would read it, 12x squared. A more casual definition would be, we might say this casually in class, that 12 is the coefficient because it's the number that's attached to the variable. So 12 is our coefficient. So all we do when we combine like terms is combine coefficients and constants. Let's go back to our example again. What we're going to do is we're going to work in terms of descending power. So we're going to start with our x squared term first. So we said that 5x squared, negative 2x squared, and x squared were our common terms. And so are our like terms. Now there's a little 1, again, implied in front of the x squared. So we have a 5x squared, a negative 2x squared, and a positive 1x squared. Well, 5 minus 2 is 3, plus 1 is 4. So altogether we have 4x squared. What I've done is I've combined my coefficients. Or, as I've just written for you here, we'll add the coefficients of the like terms. Okay, onward and upward. We had the 7x, and we said that that was the only one there, so plus 7x. I guess maybe we didn't say it. I'm just talking to you. The last terms that we have that are common, or like terms, are the 2 and the 7. And so we're just going to add them together to get positive 9. And here's our sort of simplified expression. What we did is we took a large expression and we simplify the expression by combining like terms. This is going to be a critical skill throughout the rest of your math career, essentially. So we want to make sure that we get this right. And what does this skill rely on? But your skill of dealing with integers. So we're really not just trying to give you busy work here, we're trying to hone your skills that we know tend to get in students' way. I know from teaching Algebra 2 for many years that it isn't really the Algebra 2 that makes kids trip up, it's these basic Algebra 1 skills, and some of them even pre-algebra skills. So let's keep practicing. Okay, another example. So let's see. Who are our like terms? So I just start with the x here, and do you see any other x's? 3x, you say. Good. The positive 3x and the positive 1x that are here, I'm going to combine those coefficients, my 1 and my positive 3, gives me a 4x, and then the 7 is the constant, doesn't have any like terms, it's just by itself. So what we've done here is we've simplified, right? We've simplified the expression. Not to overwhelm you, but eventually you'll notice that what I've done now is I've thrown an equal sign in here. So eventually what you're going to want to do is simplify the left side, simplify the right side, and then proceed. This is what's coming down the pike. So on the left side you already know what to do. We combine these like terms, we get 4x plus 7 equals, get the 42 and a negative 12. The x is its own little term with nobody hanging out with him. So we're just going to write x plus 30. Now, it doesn't even matter that you don't necessarily know what to do next. It's just the fact of the matter is simplifying both sides of this equation, looking at each expression individually, this expression and this one, and being able to simplify them to something easier is going to allow us to solve more complicated equations in the future. Now this is your example. Why don't you press pause and try to simplify this expression on your own. This is negative 9 plus 12x minus 10 minus 4x, in case you can't read my hieroglyphics. Go ahead, press pause now and try to simplify that. Did you get 8x minus 19 or negative 19 plus 8x? Hopefully. If not, the packet should give you plenty of practice. Now, I just wanted to give you both versions of the answer. Again, we prefer this answer. We prefer to write in order of descending power. So this is an x to the first power, and then the constants usually come last. You'll notice that most of your algebra teachers prefer it that way. Now I guess all you have to do is just work on the problems in the packet, and you're all set. Good luck, and see you next week.